Assalamu alaikum everyone. I hope you guys are doing great. So in this video, we are going to talk about vectors. The first part of this video would be about the magnitude of a vector, and in the second part, we are going to discuss addition and subtraction of vectors. All right, okay, so let's get started. I am going to share my screen. Okay, all right. So let's talk about 9.2, that is basically the second unit of the ninth chapter, that is vectors. Okay, so today we are going to discuss the magnitude of a vector. Okay, so this is what we are going to talk about today. All right. Now, obviously, we have been talking about vectors, and we know we have two types of vectors. It could be a two-dimensional vector. It could be a three-dimensional vector. It totally depends upon the scenario. And for both the cases, we'll see how to find the vector. Now, let's suppose that we have a two-dimensional vector. So the column vector is going to be xy, and we are going to write it down this way, or you can write it down as xi plus yj. Okay, so these are the two representations, and the magnitude is going to be root and then the square of the x coordinate and then the square of the y coordinate, or basically the x direction or y direction. That would be more appropriate. So x squared plus y squared, and this is going to give me the magnitude. Now let's say that I have a three-dimensional vector that is AB. So let's say AB vector is equal to xi plus yj plus zk. Since it is three-dimensional, so I'll be writing down the three x's. And now when I will talk about the magnitude, let's talk about the notation first. We write down the vector, it's AB vector. And for the magnitude, we make these two straight lines, and this is going to be again the root and then the square of all the components. So x squared plus y squared plus z squared. This is how we find the magnitude, and this is how we denote the magnitude, and this is basically the idea about it. Okay, let's talk about an example quickly. Okay, example number 1 says find the magnitude of the vector 3, 4 and 6. Okay, It says find the magnitude of the vector 3, 4, and 6. So we know that the magnitude is going to be under the root and then the square of all the components. And then you can just write it down as 9 plus 16 plus 36. And this is going to give you root 61. So this is going to be the answer. So by now we have talked about the notation of vectors in the previous lecture, and here we have discussed the magnitude of the vector. But the examiner, yes, he can ask you about the magnitude of the vector, but the question could be something that would require this, but not exactly this. Okay, so let me write down the next part. Hence, write down a unit vector in the direction of 3, 4, and 6. Okay. Now this is the next part of the question. Okay. Always remember, whenever you have been asked to write down the unit vector is just this, that if you have the actual vector, you need to divide all the components by the magnitude of the vector. Why are we doing so? We are doing so because unit vector has magnitude 1. So when I will divide all these three components 3, 4, and 6 by the actual magnitude of this vector, the new vector would basically become a unit vector. And now when I will find out the magnitude of the vector that I would make by dividing root 61, that would basically be 1. So a vector having 1 as its magnitude is basically a unit vector. So the idea is going to be same. What do we do? It's 3, 4, and 6 because the direction has to be this, but it has to be a unit vector. So for that, I am going to divide this entire vector by root 61, and this is going to give you 3 divided by root 61, 4 divided by root 61, and 6 divided by root 61. So this is going to be the unit vector in this direction. Okay, all right, okay. So this is basically the idea. Let's use the same concept and let's talk about some more questions. Okay, now it's basically a past paper question, but you guys would get to practice the idea. Okay. Part A says, find the value of k for which the vectors 2 minus 1, 6. And 8 minus 4k are parallel. Okay, all right. Now, the question says find the value of k for which the vectors this and this are parallel. So first of all, let's talk about when exactly two vectors are parallel. Okay, so two vectors are parallel if they are scalar multiples of each other. This means if I am able to multiply something over here, let's say if I multiply 4, I would get to 4 multiplied by 2 is 8, 4 multiplied by minus 1 is minus 4, and 4 multiplied by 6 is 24. So if I will have 24 instead of k, this would mean that both these vectors are parallel because this vector is basically the scalar multiple of this one. So two vectors are parallel if they are scalar multiples of each other. So having said this, we know that eight minus 4 and k is basically equal to 4 multiplied by 2 minus 1 and 6, and this comparison implies that k is equal to 4 times this number, and this is going to be 8 minus 4 and 24. So k is equal to 24, and this would mean that the two vectors are parallel to each other. Okay. The next part of this question says, find the value of t for which the vectors 5 plus t, 4, and 3 minus 3t, and 3, 4, and 9 are equal. Okay. So find the value of t for which the vectors 5 plus t, 4, 3 minus 3t, and 3, 4, 9 are equal. So when are two vectors equal? This is what we need to understand, okay? So if I talk about the solution, I can write it down this way, that two vectors are equal if all their components are equal. Okay, so this implies that 5 plus t is equal to 3 and 4 is certainly equal to 4, and 3 minus 3t is equal to 9. Okay, so I can just take this 5 on the other side, and this would give me t equals minus 2. And if I use the same equation, I would get the same answer again. So t has to be minus 2. So we can write it down this way. For t equals minus 2, these vectors are equal. Okay. All right. Okay. So this was basically an idea about the magnitude of vectors, and this is how exactly it is used. Okay. Now let's talk about the next topic, that was nine point three, addition and subtraction of vectors a geometric approach. Okay. All right. Now here we will talk about addition and subtraction of vectors using the geometric approach. Okay. Let me explain that through a diagram. So this is a triangle. Okay. This side is A, this side is B. These are vectors because we have direction, and this is AC. Okay, now we can say that AB vector plus BC vector is basically equal to AC vector, because certainly in this part we are going from A to C, and in this part we are going from A to C. So by adding two different vectors, I got this one, right? So same would be the case if I talk about another random directional path. Let's say I have 1, 2, 3, 4, 5, and then 6 sides. Okay. Now this basically is a hexagon. This is F. It's A, B, C, D, E, and F. And the direction is A to B, B to C, then C to D, then D to E, then E to F, and then A to F. Okay. Now I can write this thing as vector AB plus vector BC plus vector CD plus vector DE plus vector EF is basically equal to AF vector. So by adding a few vectors, I got this vector, and both the right side and the left side of the equation are same, right? So this is basically a concept about this topic. All right, okay. So in order to understand it better, let's talk about one last example. Again, I'm going to make a triangle for this one. So this is O, this is A, vector is small a, then this one is small b, this is b, okay. And then we have AB and the direction is this, okay. Now let's say you have been asked to find out AB. So what is an alternate way of going from A to B? So what do you guys think? You clearly know that this A is basically in this direction, but if I am interested in going from A to B, I would have to go in this direction. So if A is for the opposite direction, it would be minus A for this direction, okay? So minus A plus B. So basically by adding and subtracting vectors, I am able to go from one point to the other. It's completely fine if according to the diagram you think that you can't go back. But you know that A is basically the vector in this direction and I want to go in the opposite direction. So if A is the vector in the opposite direction, it would be minus A and then plus B would come as it is because obviously I am just going to add that directly. All right, okay. Now let's talk about some questions to understand the concept properly. Okay. All right. So this is basically question number 1, and it says A is a point with coordinates 1, 0, 3, and B is a point with coordinates 3, -2, and 6. It says find using column vectors AB and the position vector of the point C, which is the midpoint of AB. Okay. All right. Now for this question, the diagram is not there, but you need to imagine this. It says A is a point with coordinates 1, 0, 3, and B is a point with coordinates 3, -2, and 6. Find using the column vectors AB. Let's talk about the solution of the first part, AB. So this is basically the coordinates of A, and I told you guys this would basically be the position vector, and this is the coordinates of B. So this is basically going to be the position vector for B. And now if I'm interested in finding out AB, I told you we write it down as OB minus OA So AB was with these coordinates 3, -2, and 6. And then minus sign. And then OA was with the coordinates 1, 0, and 3. And now when I will find the difference, 3 minus 1 would give me 2. -2 minus 0 would give me -2. And this would give me 3. So these are going to be the coordinates of AB. Second question says, the position vector of the point C, which is the midpoint of AB. Now, when we have the coordinates of AB, think about that as the position vector for AB. And if something is lying in the midpoint of AB, so for that, we are just supposed to divide that by 2. So midpoint means I am going to do 1 by 2, 2 minus 2, and 3. Midpoint of AB would basically mean 1 by 2, the AB vector, okay? And this would give me 1, -1, and then 3 by 2. So this is going to be the vector. Okay, 1 second. This is basically going to be the midpoint of AB. And now we are supposed to find out the vector OC. Okay. All right. Okay. So this basically meant that we were asked to find out the position vector of the point C, that was OC, and I know that AC is basically going to be OC minus OA. So for OC, I'll do the vector AC that I got by dividing it by 2, by dividing AB by 2, plus OA, which I already have, and this is going to give me OC. So AC was 1 minus 1 and 3 by 2. OA was 103, and when I am going to add this, it would give me 2 minus 1 and then 9 by 2. So this is basically going to be the answer, okay? So the question was not about finding out the midpoint of AB, it was about the position vector of the point C. When it's about the position vector of point C, that basically means we need to find OC. And OC is going to be what? I know that where exactly I would get OC. I would get OC in this expression. AC is equal to OC minus OA. Now I need to find OC, so I made OC the subject, and the remaining things came on the right side, on the left side. I got AC by dividing AB by 2, and OA was already given. After adding the two things, I got this as my answer. So this is how we add and subtract vectors, and this is where exactly it is used. So I hope that you guys were able to understand everything, and if you have any questions, any queries, you can just use the link in description to get yourselves enrolled for our live classes. So take care all of you, and Allah Hafiz.